In this section of chapter 4, I would like to discuss titration problems and go over a number of such problems. Some of you have done probably experiment like these in other chemistry class. This is what you're looking at is the method by which titration is done. Now say for example you have a solution of an acid and you want to know its concentration. Then what you need to do is you need to let it react with a base, because we know that acid and base, they react, giving a salt and H2O. So in this particular case, the sample of acid whose concentration has to be known is in here, and then you are filling sodium hydroxide in this burette. This is called burette. And then you add an indicator so that when neutralization had happened, if you have one extra drop, the color is going to change because extra drop would make it basic. So that indicator would show that it just got basic. So you take the acid and keep on adding sodium hydroxide few drops at a time, or even one drop at a time, and then start your solution. When the whole solution turns just pink, you stop adding. That means you just crossed the neutralization point and you have probably one drop in excess. So then from the volume of sodium hydroxide that you added, you can calculate, of course you have to know the concentration of sodium hydroxide, then you can calculate the concentration of the acid. Once we do problems, you'd understand the calculation part of it. Let's begin with homework problem number 81A, page 153. In this particular problem, in 81A, question is asking for the volume of HClO4. They gave you the concentration of HClO4 is 0.115. So let's write down that 0.115 molar HClO4. So they have given you that concentration. They're saying that what volume of this acid is needed to neutralize 50.0 ml. So let's write down here 50.0 ml, 0.0875 molar, 0.0875 molar sodium hydroxide. So the question is asking for the volume. Okay. Now, in this particular problem, they didn't give you the reaction. Even though I wrote down the reaction, I would like to explain to you how we came up with the products of the reaction. Let me show you that HClO4, you can think in HClO4 as HClO4, and you can split that into H plus 1 ClO4 minus. And then NaOH, you can think in terms of Na plus 1 and OH minus 1. This whole OH is minus 1. In this kind of reaction, sodium is going to replace H, and H is going to take the place of sodium. So let's have the H in here, and let's use a different color. Sodium takes the place of hydrogen. Now let's put down these side by side, and that's how you get Na plus 1. If you look at the product, Na plus 1 combines with ClO4 minus 1, so this is a 1 and 1 product, plus H and OH makes H2O. Now you need to then balance the reaction, but this reaction as it is not balanced, so I don't need to do anything, so I can work on this problem. Now let's write down that how this reaction happens. 1 mole of HClO4 reacts with 1 mole of NaOH, giving 1 mole of NaClO4 and H2O. is the same molar ratio. So if you have the same molar ratio, let me highlight that. If I had 1, 1, 2, 2, then that's the same molar ratio. We can apply the formula. Let me write down that formula. Molarity of acid times volume of acid equals to molarity of a base times volume of a base. If you multiply that, Ma, which is moles per liter, if volume is in liter, you get moles of acid. And similarly, Mb times Vb gives moles of a base. So that basically is saying that these moles are the same. And in this particular reaction, that is the case. So be careful before you use this expression. Make sure number of moles of acid or not, as well equal to number of moles of base. That is the case here, so we can use it. Okay, now I'm going to now do the problem. I first need to get the volume of acid, because which is missing. You can see here they want you to find out volume of acid will be given by molarity of base times volume of base divided by molarity of acid. Let me double check, make sure I haven't used any wrong number here. So molarity of base, we already know, is 0.0875. It is given 0.0875 molar, and the volume of base is also given, which is 50.00 ml. Now I would like to get my answer in ml, so I didn't change it to liter. Now molarity of acid at the bottom, which would be 0.115 molar. This is also given molar. Now if you do this math, you're going to get 38.0, and the unit is going to be ml. Let's double check the unit so that you'd know that that's the right unit we're getting. Molarity would cancel out, and only ml is left, and that's the final unit for this. So our answer to this question is 38.0 ml. So that's the answer to this question. Let me now go over problem number 81b. In 81b, again, this is the titration problem, and they're asking what volume of 0.128 molar HCl is needed. So let's write down that this given values. So 0.128. So let's write down 0.128 molar HCl. So let's separate them so that I don't get confused. So 0.128 molar HCl, and they're asking the volume. So question mark. So what volume of 0.128 molar HCl is needed to neutralize 2.87 gram MgOH2. So obviously we need to write down the reaction between these two compounds. HCl is an acid, MgOH2 is the base, and first you need to write down the products, and then you need to balance the reaction before you do the problem. Okay, now let me show you how we can predict the products of this reaction. Again, HCl you can write down as H plus. Let me write down here the way it's shown. H plus Cl minus. So that HCl. Now I'm going to write down in ionic form MgOH2, Mg2 plus, and OH minus 1. You can always look back and double check. 2 goes underneath OH, and 1 from OH goes underneath Mg. So that checks out, is MgOH2. Now, how would I get the product? This is a double displacement reaction. Most titration reactions are double displacement reactions where two ions exchange their positions. So in this case, let me show you. H plus takes the place of Mg and Mg takes the place of H plus. So if that happens, let's see what would be the formula. Now don't change the charges on individual atoms or OH as a group. So Mg2 plus goes with Cl minus now. So Mg2 plus goes with Cl minus now, which is -1. Now placing H with OH minus. So H plus 1, OH minus 1. Now let's write down the formula now. So whenever you write down like this, especially on MgOH2, we don't copy the 2. We wrote down like this. That's automatically, that tells us that 2 from Mg, you'd go to the bottom of OH when you write down the formula. Okay, now let's write down the final formula for the products. MgCl2. I'm assuming that all of you understand this. MgCl2 plus HOH, that gives H2O. So that would be the very first step to write down the products of the reaction. So let me do that now. And after drawing a line here, HCl plus MgOH2, that gives, I think I'm going to use a different color so that we have a better way of tracking. MgCl2 plus H2O. So these are the products. And I've already shown you how we got those products. Now I need to balance it. MgCl2. Now I have only one Cl on the left, two Cl on the right. So you have to multiply HCl by 2. So that's 2 HCl. And I have 4 hydrogen now on the left and only 2 hydrogens on the right. So multiply that by 2. So that gives you 4 hydrogen and 4 oxygen. I'm sorry, 4 hydrogen and 2 oxygen. So that's the balanced reaction now. Now, once it's balanced, now you can do this calculation. So start with 2.87 gram of MgOH2. So let's write down 2.87 gram MgOH2. And I need to get mole first. Magnesium is 24.3. Make sure you look at periodic table. 24.3. And oxygen is around 16. Hydrogen is 1. So that's 17 times 2. That's 34. So plus 34. That's gram, giving a mole. MgOH2. I think I don't have enough space here. So let's write down here underneath gram of MgOH2. Next step. From MgOH2 you need to calculate HCl because the question is about HCl. So we have to go there. So chemical reaction is going to help us. So let's write down. You can see here that I would have 1 mole MgOH2, 1 mole MgOH. I think again I don't have space. 1 mole MgOH2 on the bottom and 2 moles HCl on the top. 2 mole HCl on the top. Let's see what I can cancel out at this time. Gram MgOH2, gram MgOH2 to cancel out. Mole MgOH2, mole MgOH2 to cancel out. That gives me mole of HCl. And the value is, let's write down the value. 0.0984 mole HCl. Now, did we get our answer yet? Answer is no, because question is asking for the volume of HCl. And we got mole of HCl, and we also know the molarity of HCl. So let's write down that now 0.0984 moles, 0.0984, that's the mole HCl be given by molarity, which is 0.128. Let's draw this. We're doing this problem in several segments so that you understand it better. So now molarity we're going to use, which is given 0.128, and that's moles per liter. That's the given information about HCl. So moles HCl per liter times the volume in liter, that will give you moles. And that's the volume you need to find out. And we already know the moles of HCl because we already calculated the moles of HCl. And that will be given by molarity times volume. And that's how I set this equation, that's a math expression. The volume would be given by, when you solve this, you're going to get 0.769 liter. 0.769 liter, and if you multiply that by 1000 you get 769 ml. So that's the answer to this question. We need 769 ml of HCl in order to neutralize MgOH2. Now I'd like to go over problem 82a. The question is, how many ml of 0.120 molar HCl needed to neutralize 50.0 ml 0.101 molar BaOH2? Again, we need to look at the reaction between HCl and BaOH2. First, split this reactions into pluses and minuses. So H is going to be plus, Cl is going to be minus, Ba is going to be plus 2, and OH is going to be minus 1. That's how you got BaOH2, because that 2 from Ba went to the bottom of OH. Now, in a double displacement reaction, barium is going to take the place of H+, so that's how you're going to write down. And we write down metallic part before non-metallic part. So first we're going to write down Ba 2+, and then Cl, because remember that Ba took the place of hydrogen, and hydrogen takes the place of Ba. So you'd have hydrogen plus 1 and OH minus 1. So now the products would be, let's write down with a different color, BaCl2, because this 2 from the top of Ba went to the bottom of Cl, plus HOH is same as H2O. So now let's balance it. I have 2 Cl on the right hand side and 1 Cl on the left hand side. So make sure to multiply HCl by 2. So that 2 HCl. Now I have 4 hydrogen. On the right hand side I have 2 hydrogens. So let's make it 4. Let's stop and think whether I balanced it right. Yes, there's no problem with the balancing. So now I can begin the problem. You can do this kind of problems in more than one way. I'm going to show you one way, but which is like a 2-step calculation method, but this can be done in 1 step. So let me show you the 2-step. I think you probably would understand better if it's shown in a broken parts. So in one part would be, I'm going to calculate the mole. So let's do that. 0.101 moles per liter of barium hydroxide. Let's begin with that. 0.101 moles per liter barium hydroxide OH2. Let's draw a line. So 0.101 moles per liter of barium hydroxide times volume in liter of barium hydroxide, and we know the volume is 50 ml. So that's divided by 1000 gives liter. So 50.0 divided by 1000, that gives liter of barium hydroxide. So if I cancel out, I get moles of barium hydroxide. Let's do that so that we can follow the units. Liter would cancel out. So I get moles of barium hydroxide. And now, from moles of barium hydroxide, I can get moles of HCl. So by looking at the reaction, you get this relationship. 1 mole of BaOH2 and on the top you'd have 2 moles of HCl. And the value that I get is 0.0101 mole HCl. Let's double check whether we are doing everything right. It's a good idea that we didn't copy anything wrong. So that's how we can make sure that the problem that we're doing is right. Okay, now we got moles of HCl, 0.0101. So what I'm going to do next, again, I'm going to use mole of HCl, 0.0101, that's mole HCl. That's given by molarity of HCl, which we already know. Molarity of HCl is 0.120. 0.120 moles per liter times the volume in liter. Okay, and the volume will be given by, if we do this math, 0.0842 liter. 0.0842 liter. And you can express that in ml, which would be 84.2 ml. So you go from liter to ml by multiplying by 1000. And that's how I got this answer. I think this is not very clear. Let me rewrite this. For some reason, I could not write it well. So if you multiply by 1000, you get 84.2 ml. I think it looks a lot better now. And that's the answer to this question. Now, I also mentioned that you could have done the whole thing in one step. And let me show you that in the setup. That means I didn't have to do this part separately. I could have done everything in one step. And you can try yourself, but it's basically the same thing.